Now, this intro is going to be very short until yesterday when the RSGB AGM took place, and the number of mentions of microwavers was legion. So let's start with Murray, who was announced as an RSGB Life President, so for all the work he's put in, so thank you, Murray. Then Barry was awarded the Calcutta Key, is that right? Yes. For his efforts on 23 centimetres, etc., and all the wider support to IARU, so thank you to Barry, we'll hear from him later. Graham Sherville got Louis Varney Cup. Chris Whitmarsh was recognised for operating all bands that we are licensed on, from 73 kilohertz to 241 gigs, is that right? So he got an honorary mention and recognition. And last but not least, Heather not only won the software section of the construction competition, but she was the overall winner of the construction competition. So microwavers were legion. Have I missed anyone out? There were just so many listed yesterday. Anyway, congratulations to you all. The intent is to have a photograph of you all together that we'll hopefully get into Radcom and show the world that really the world revolves around microwaves. So, phones to silent please, if you haven't already done so. And any questions before we begin? Okay, so Lehane is going to talk to us about the evolution of the VK122-134 gigahertz systems and future possibilities. Lehane, of course, as you know, is one of the original members, particularly along with Steve KNZ of the UK Microwave Group. And of course, a while ago, there were lots of mentions of the VK equipment. They were all being imported, and many people acquired them in the UK. So it'd be really good to hear from Lehane, A, how they're working, and B, how every single person who's bought one is operational. So, Lehane, over to you.
That's right. Just get some of this technology. I'll read the news later on. Failed at the first attempt. There we go. That's the basic. Okay, cool. Good morning, everybody. Right, so hopefully we'll get some more interest going on these systems, because, as Graham said, there's lots of them out there. So what I want to talk about today is how we've got where we are. So talk a little bit about the silicon radar devices, what some other people have done, because it's not just the VKs that have worked on this particular approach. There's a couple of other people who have done so. We'll run through how it's evolved, talk about some of the experience that I've had and perhaps about some of the others. And I know it's only new, but maybe there are some things we can already do about changing and improving the design of the new board. And then a little bit about some add-ons. We wouldn't be where we are now without these guys. You know, if you've done anything with the VK boards or been interested in these very high frequency millimeter waves, then what was Silicon Radar, now Indie, have been very, very active in getting these available. Been around for some time now, quite a number of years, originally with the, doesn't work. Oh yeah, it's only class 1A or 2A or whatever it is. Yeah, okay, just there. So this was the first design with the patch antennas built in. And apologies if I'm covering things that you may already have known. You know, there have been previous talks, I know, but I think it's worthwhile just covering these off. So original one with the patch antenna, then the next version came out with the integrated antenna, moved on to the version that I'm going to talk mostly about today, which is the version that covers 134 gigahertz, and then maybe something else in the future. The guys over in Frankfurt are pretty easy to deal with, so if you do want to buy the devices, it's not a big deal to do so. They only deal direct, clearly as a minimum order quantity. But the process is pretty easy. Just fill in the forms, tell them why you want to use it. You're not using it for stealth technology. It's just for amateur radio use, and go through the process of quoting an order and then sending the money, which is the more difficult bit. They have a shipping and handling fee, which is 130 euros, so buying one would not be effective. But buying 10, which is what I did initially, works out at £82 each, so they're more expensive by some order than the 120 gigahertz on their own. So, as I say, the VKs are not the only people who've been active with these devices. K6ML has, I think he still has the world record for 122 gigahertz, but he used the original device in a little system, and because you can see these antennas are physically separate by quite some margin, he actually used stepper motors and a lead screw to move the chip and the PCB assembly backwards and forwards inside the focus of the dish. So that's quite some approach. And there's an amateur in Japan, JH1CJN, otherwise known as SSKMBK on X, Twitter as was, who basically breadboarded a very successful system using the new chip. And it's been interesting to watch how he's evolved this system and get it working. And no problems on 135 gigahertz with the proviso, at that time and the temperatures. But yeah, as you can see here, there is plenty of output at 135 and it's locked. And he's not using a particularly low noise synth either. I think it's a Max 2871 or something like that just there. So, you don't have to go the whole way. You can literally put something together with breadboards. Inside there is just another QFN adapter like that. So, yeah, plenty. One of the things that you do have to do is, though, V-tune, which is the tuning for the chip, has to be quite high. You're up to almost maximum allowed on the device at 5 volts, so it's getting pretty close, but that certainly works fine. Another VK, VK5KK, put together a system which is more modular than the one that we're perhaps more familiar with, the VK3CV. And this uses a daughter board approach. You can see there it's got one of the backwards. Back. Yeah, okay. There's a lag. There we go. So this has got a daughter board, and as you can see here, it's got one of the old chips on. They've then upgraded it to use the 122 gigahertz only, and then subsequently to the 122, 134 gigahertz. Slightly different again, that it's got an Arduino compared to the VK3CV board, which has got some advantages, but is a bit more power hungry. I think somebody in the UK has actually had the boards, but I don't know of many people who've got them. It's not something that's become popular here. I don't think it's actually become popular worldwide because the kits weren't available. It was just the PCB designs, go out and get a PCB house to build it for you. But yeah, that's the one approach. Right, let's try again. There we go. So then came out the original, the VK3CV, get it right, design, and it's been very popular, convenient, as I say, you just power it up and go, put your choice of antenna coupler on it, and you've got a system. You only need an IF system and a rig and a few switches, off you go. I don't think many people built them from scratch. I think everybody bought the boards completed, and it's got pretty low power consumption, sub 200 milliamps, so it's quite convenient for portable use. And I don't know how many exactly were made, but I think it's certainly into the hundreds, and quite a lot of them came here. But I don't quite know where they are, because they're not all on the air. I know a lot of people bought two, I understand that, but even so, there should be, you know, a bit more noise on 122 than there currently is. And PCB, which I'll refer to quite often, is the 003. They've got some quite old firmware on it at the moment, but yeah, it's quite a system. Don't think there's much else to say about it. Oh yeah, one thing I will talk about is the synth. The synth on this is ADF4153, so that's quite an old device, and that has some problems. Yeah. So one of the things about the 122 system is it is just on 122, and with the availability of the new chip, one of the things I looked into was why not upgrade it to 134. So I spent some time looking into it. Not too difficult. First of all, change out the chip, of course. Add a regulator to give the PLL 4.7 volts, 4.75 volts. You need that because the existing 4153 PLL chip is fed directly with 3.3 volts. So it won't tune high up to 134 gigahertz without that LDO change. A few links and things to change, and of course new software, because the chip, some of the things like enable lines on the new chip are the opposite of the 122 gigahertz chip, as they do. So if you just leave it as is, you know, receivers not enabled, transmitters not enabled, it won't work. It's about 2 hours work to do the upgrade. It's not particularly difficult. As I say, there's other than a couple of cut tracks, but you do need to have the facility to do a QFN rework. So ideally a hot plate and hot air gun. You probably could get away with just a hot air gun. The chips are not particularly delicate. I've had one of them in and out 3 times, just doing things to testing it. So it's pretty rugged. And you know, the cost of the upgrade is £85, so it's not a very expensive upgrade, but clearly, you know, it's an additional cost to do that. And the details were published, including all of the board changes that are required in Scatterpoint some time ago. So about the same time, in fact probably a little earlier, in fact, the VK3CB guys got hold of some pre-release chips, which never made it to the general market. I think it was the 034 version. And they had to play with going to 134 with that. And Silicon Radar discontinued that one, came out with the 045 chip, which was specifically designed to cover up to just 134.1, although it does go higher. But that was the design brief, I understand. And so they took the opportunity to upgrade the board. For those of you who get to this, the last version, last issue came out with the details on that. So what have they done? Well, first off, they got rid of this. They got rid of the old PLL and changed it to a much better synthesizer, the 41513, which is lower phase noise. Has a 49-bit divisor, so you can do pretty much anything you want with that chip. They've also added 100 megahertz VC OCXO, which is again, very low noise. It's also very expensive. So, you know, you get swings and roundabouts there. So there's no longer a 10 megahertz reference. There's no point, you know, chopping out the 100 megs and putting in your own. This Fabricon is very low noise. It's very nice. And the other thing that's been added is the IQ switching is built on the board. So those of you that did the Gen 4 ASM modification and put IQ switching on board, no longer required. It's all handled with the microcontroller. And firmware again, it's now getting a year out of date, so I'll talk a little bit about some of the things that can be done to make that slightly better. So I talked about the synthesizer, and this is some of the things that I've observed about this board, the old board. So when I say the 003, I'm talking about the older board. That's the plot at 122 gigahertz. That's an 80 megahertz total span. You can see the spurs on it. It's noisy. Your output power is going to be spread over that spectrum. So, you know, it's not great. And, you know, anybody who's been out in the field, particularly if you've got things like 705 and somebody's close, you can just see the sprox everywhere. You know, it is noisy. But, you know, at the time, it was probably a sensible choice to use the 4153. It was a relatively well-known synthesizer. Adding the LDOs, there are 2 low dropout regulators on the new board. And because of that, that's helped the phase noise as well. So they feed separate areas of the circuitry. One is dedicated to the synth and one for the chip. They do actually run at 3.6 volts against 3.3, which is absolutely, again, at the maximum rating for the chip. So one of the things I think will be interesting is, you know, does that affect chip life? Probably not in the amount of time we're running them, but it's certainly something to think about. But yeah, 3.6 volts on a 3.3 chip. One other thing I think a lot of people have already done is take off the MMRT switching regulator and put a linear regulator in. I like the LM2940 when you can get them, but you know, a lot of things are better than that. The MMRT isn't that bad. I mean, you know, it's pretty good, but switching regulators and RF systems close together in proximity wouldn't be my first choice, but I can see why they've done it. The other thing that's worth doing, and I don't know who's had brownouts on their board, anybody? No? Okay, so certainly there was some discussions about having brownouts on the original board where there'd be a power droop and the PIC would hang up. It's worth just changing out one capacitor and putting in the little supervisory IC that Microchip provide. It's designed to handle PICs. It works alongside the programming port. It's a little 3-terminal device. You literally take the capacitor out and put in the supervisor chip, and it's all done. So that's quite good. So that's the old board. I don't think they've got anything else to really say about that. I mean, it's out there. It's being used by a number of people, and long may it continue. This is the new board. That's much cleaner, isn't it? That's really quite an improvement. Same span, 80 megahertz across at 122. Note a couple of side spurs there, but they're not too bad. A little couple of integer spurs, but it really is a lot better than the old board. And it'll be interesting to see whether or not that helps with range, and whether we get better DX out of the new boards. The board version is called the 007. It's interesting that both Dubus and pretty much all the photos on the Groups IO website are actually versions that aren't the 007. So it's been interesting building one by hand. It's a few anomalies. So there's just a few components that are misplaced on the diagram and a few pads that are not used, and just this kind of general tidy up that was needed in order to get it up and running as spec. But yeah, the guys have done a lot of work. The amount of work and effort that gets into getting that board done shouldn't be underestimated. 4-layer board, 2 gigahertz is the synth output. So it's a significant amount of work. And you have a number of different areas. You've got synth chip here that pick. This is, of course, the actual radar device which we're using out. 2 LDO regulators, and then most of the rest of this is just either IF interfacing or, and it's just there, the control circuitry for the Abracon, which is the expensive oscillator. They come out at the moment at about £80 as well, so that on its own is about the same price as the radar chip. The other thing to note about it is it's quite power hungry. At startup, somewhere around 700 to 800 milliamps until the oven's warmed up, and even after that it's drawing about 500 milliamps continuous. So your small gel batteries, if you're used to running those, are not going to last very long with half an amp draw. So it's something to think about if you've been used to using a 705 with the internal battery and a small gel cell. Not going to run. One of the things, again, about the shakedown of the board is that it's not particularly friendly for front mounting. I know most people tend to put them in a die-cast box and mount them quite close to the front panel, and then you have all of the connectors at the back. But if you try and do that, there's a few issues with that, one of which is just there. So this is the SMA output for the IF, and just see there's a capacitor under it, so you can't mount it flush to the board. So although it's M144, you've still got to stand it off. It's just, there's acres of board space here to have moved it 3 millimeters left. Not quite sure why it wasn't done. If you fancy building one, I've got some PCBs. There's about 220 components, I think, on board, something like that. 0603 is the smallest. Yeah, it's quite a job, And for those of you who were out in the field a few months ago, it's months now, isn't it? It's been raining so much since. Forget that. Last trip out, I had problems with this board, and I couldn't hear very much. So there were 2 issues. One of which is, pretty standard for a new startup, was that the dish wasn't a very good one. And this was a standard 45 centimeter satellite parabolic dish. Focus was in the right place. It was dead. Moved to a VSB dish, fine. That's slightly smaller, but had more gain. So again, one of the things that I know a lot of people have got experience with is which is the best dish for 122, and it's trial and error. Unless you've got one that people have used in the past. The other thing that was wrong was this device, which is part of the IQ switch, and I think it's 2 millimeters, it might be 3 millimeters square, with 6 lands, including a ground plane in the middle. Okay? It's great. And that was the thing that was dead. Now, whether it was dead because it wasn't soldered in properly, and you can't really inspect it because, despite the fact it's in a QFN-like package, you can't really see whether everything's connected underneath. So I took it off, threw it away. I mean, they're not expensive. Sadly, you can't get them in the UK. They're a Skyworks DP-DT switch, so they have to come out from the States. But I had a few spares. And swapped it over and made sure it was really down on the board, and went around the outside, and as you can see, there's plenty of flux on that, and it worked. And boy, was that a big difference in the amount of signal that came out. It really was. So, you know, it was annoying because I could hear something, but it wasn't as strong as expected. You kind of go through all the things that you might have done wrong. It's a, I don't know, $2 chip, something like that. So I know there's been a lot of interest in this board, and I know how many people have actually gone and pre-registered for? Well, quite a few, okay. So I think now it's about a year since it was kind of pre-announced. This is purely my guess, I've got no inside information. I guess probably pre-Christmas to get them, and probably about £375 to buy. As I say, you know, 2 of those components in small quantities are £80 each, and then you've got, you know, the LDOs are 7 each. You just, this goes on. So it's not going to be particularly cheap unless the volume's really high. The other issue about the timing is, last time I checked, the Abracon 100 megahertz oscillator was on 6 months lead time. Interestingly, the 3.3 volt one isn't, but this board is designed for 5 volts. And again, you know, if you knew that now, you'd probably think about changing the design slightly, because the pre-scaler will take the input at 3.3 without any problem. So, yeah, it's an issue. So I guess we've got about 5 to 6 months to wait for these to come out. So what can we upgrade it? I know it's only just coming out, but you know, always looking to do some changes. So as I said, the synthesizer chip has this 49-bit fractional integrator. You know, I'm not a P-level guy. For those that are, they will know all about the ability of 49 bits and what you can do with it. And one of the things you can do with it, of course, is move in very, very small steps. Even at 122 gigahertz, you can move just a few hertz, which is quite useful for some things. So that's, you know, one of the big advantages of this. And currently the software, the firmware in the PIC does not make use of that. It's pretty much treating it as just a 25-bit system rather than a 49-bit system. So there is a possibility to change the PIC out from the existing 16F to an 18F, which is faster, it's got more memory, and same price. You know, it's £5. PICs are £5 pretty much everywhere. And for those that like programming in C, it has that advantage. The C compilers are available for it. So it's something to look at. The other thing that there's always some complaints about is the audio quality out of the boards. And I still think there's some mileage in putting in one of the SL6270 Vogats in as ahead of it and then winding down the gain on the main board. So, not big change. And again, it's used the same switching regulator, so swap that out for linear. One of the things is it's going to dissipate a lot more power. So compared to just the watt or so that you'd have dissipation in the old board, the new board you're going to be looking at 5 to 8 watts at startup. So that's going to require some heat sinking. Not a problem if you're using a die-cast box, which I know a lot are, but it's only got some minor improvements because there are already 2 low noise regulators after that, which feed most of the supplies downstream. So, the new board's got IQ switching. I know a lot of people said, not worth it, why bother with all that? So I did a little test, and if this works...
Quick demonstration of the IQ switching and the effect on signal levels on the new VK3CV 122-134 GHz board. The IQ 755 is set up for -3 dB reference level and 0 RF gain, that's with that very close path. on the correct sideband at the moment, and I'll switch. And this is done with some modified software. And you can see the difference. I'll switch back. There we go. The software lets me select high or low as appropriate.
I mean, if you're on a path where the signal's marginal, that's going to be quite an improvement. Oh, sorry, it's an improvement if you're on the right sideband. If you're on the wrong sideband, of course, it's not. The software on the PIC picks which sideband depending on which way round the IF is compared to the transmit frequency. So that's already built in. I purely put code in there just to try out, see if it makes a difference, and it does. Certainly something worth having in the code just to try on a path in case for some reason the PIC was programmed incorrectly, or it's picked the wrong sideband, or the wind's in the wrong direction, but whatever, it's easy enough to swap it and try it out. So for those with the 003 board, the old board, and the ISM, I don't see quite so much change on that. That's, you know, quite a few dB improvement from high to low. So I think it's something to think about for looking at the ISM as to whether there's some issue with that.
Quick demo.
Okay. The other thing that's been talked about is with the new board, the channels aren't in the right places. Okay, so if you're on 122.4 nominally, and if you want to go up to 134.4, you've got to change some channels, either by flicking a switch or doing whatever you want to do. The new board doesn't have a switch on board, so everything is externally controlled. So you could get away with just two switches, one for AB and one for 122, 134. But if you do that, at the moment, it'll put the channels in the wrong place. You won't move to 134.4. So what we really want to do is, for channel 4, when you flip it up, it comes to channel C, and channel 5, which is B, becomes channel D if you flip up the switch. Right now, they're in the wrong place.
Just as confusing as it is on the current units.
Yeah. Well, okay. There's always a solution to that. So we want to make C and D to be based on 134.4. That's the easiest thing to do. All you need to do is reprogram it. And it is a very easy thing to do. So as long as you've got a PC and PuTTY, and I think most people have got PuTTY on their systems, plug it into the RS-232 port on the new board, and as we're moving frequencies, we might as well move to our other nominated channel, 134.928, and those are the 4 commands you type in, and it's done. You've now moved it so that flipping the switch to move from 122 to 134 will move you from 122.4 to 134.4. Does that make sense? The only thing I'd say is that if you do that, there is a command to restore the defaults, and if you restore the defaults, you'll have to do it again. Or the other solution, which is just as easy, is just blow new firmware in it. It's a few seconds work. If there's any interest, maybe at some other round table, you just bring along the kit to do it, or send out a hex file if you want to do it yourself. It's easy enough to blow in new code. So what have I done so far? As you may know, I enjoy working on software, so as much as the hardware. So I've done some changes, added the high and low. I've added a V command because one of the issues with it is that you can't find out what version of code you're running until you start board up. So it's nice to have a command that just gives you which version of firmware you're running, and I'll explain a bit more about why I want to do that later on. And I've done the coding in firmware to set to the UK defaults. If you want any other changes, making ahead of anything else, just let me know and I can figure it into the code. Other channels, different frequencies, it's easy enough to put it hard coded in, or as I say, there is some PC firmware, software, which lets you decide what frequency, what IF, and it just gives you the commands you need to send. And that's available from the Group's IO website. So in the pipeline is what I talked a little bit earlier, is changing the ADF4153 code to use the third register to give us 49 bits. Why we want to do 49 bits? Well, digital modes. So in doing so, it will enable, certainly first off, some beacons, just to see whether that works, and possibly Opera in at the same time. You'd have to preload the Opera sentence basically into the code. The other thing that's possible, having had a chat with Andy, JNT, he's done something similar, is to put a tone detect, which then moves the synthesizer. So you don't actually put any code in the device for the digital mode. The digital mode just follows the output from your PC. So instead of your PC audio going into your rig, it goes into this, and you get the digital mode. As I say, I've talked about the migration testing. So whilst it's easy enough to get them up and running, particularly if you've got two of them, if you're going any further, you often need some test gear. So two systems is definitely the best approach to do that to start with. Maybe just one with a horn, and then you can use the other with a dish and align them. I've found that when I was doing first setups, I was doing it over a 12-meter path inside the flat. I didn't find any difference when I moved out to 1K. So, if you get a reasonable distance indoors, I found that okay. I suspect there might be a slight tweak, but frankly, the movement required in some cases for the feed horn is only a millimetre. So, if you're trying to find out whether it was or wasn't good, you probably moved it anyway. So, set it up, you'll be good enough. If you want to look at on the spec an, as I said, the systems I've got don't go up to 134 gigs. It's much lower in frequency, but mixers work fine. I mean, if you've got a W, great. But currently there's some crazy price on the surplus market, and more on eBay. But yeah, that's probably the best you're likely to get, unless you're going for one of the Hughes mixers. If you haven't got a taper transmission, just button together. It's at this frequency, it's only going to be indicative measurements. You're not going to be accurate for most things, and coupling to the chip isn't good, which brings me to my rather cheeky bit on the right, which is if anybody's got one of those, I want it. That was, I think, made by Neil DBN. I don't think here today, is he? He's not well. But yeah, that couples from standard waveguide into the chip, and that would be very useful. That measurement's possible. You can either use lower frequency heads, calibrated in some way. There's an Amritsu head which is available, and again, lower frequency ones of those are pretty good. Roger's got quite a lot of experience of using the Amritsu heads. And there's the VDI Ericsson, which goes to 2 terahertz, which is some piece of engineering, using silicon wafers as heaters to preheat the device. So, how many here have got the LCD displays? I think a few, yeah. Right, not so many perhaps. If you want to use it with the new board, it's relatively straightforward to just change the channels. The codes there, if you've got your sketch open, all you need to do is go in and change those, and ideally take out the IQ code, because that's no longer being switched from the LCD box, but not particularly difficult. If you've got one of each, then it would be possible, and again, if there was enough interest, I can do this, to make it switch between the old board type of configuration and the new board type of configuration. And if you do the changing the orders, then you also need to flip those around. So that was one approach. The next thing on is perhaps to create a new version of the LCD and combine it with Barry's weather box. and sort of started looking at this just after Christmas. Got the code off Barry, had a little chat, and I've gone with an ESP processor because that gets a web front end. So instead of trying to put all of those parameters in on a little keypad and LCD display, you just use a web browser, whether it's a phone or a tablet or PC or whatever else. You can just load all the values in, and they're there both for the CW keying and for the weatherbox code. So it's an easy interface. You can override the GPS distance, so the GPS is moved out to the weatherbox instead of having it inside the housing, and you just feed the 1 pulse per second out to the VK3CV board. Also, the other thing is it adds a link to the VK3 PIC, so the PIC on board is now talking over what was the GPS serial lines, and that allows things like being able to download directly to it. And finally, it's got a 5x4 keyboard instead of the 4x4. So this is a prototype. As you can see, it's a bit bigger than the other one, but it's much clearer display, and I'll show that.
Just a quick question from Dave G8KMH. Did you say that the HP 60 GHz SA mixer works on 134 GHz?
Certainly does.
Oh wow, amazing.
Yeah, if you've got 11970U, which is the 60 GHz mixer, works fine. Those pictures were taken with that 60 gigs mixer, so that's pretty reasonable. So the software supports both the old board and the new board. There's a configuration list, and you just scroll through it and say, this is the board I'm using, and it sets itself up correctly. You can put in the channels and program the frequency directly, so you don't need a PC. It's not really something you likely do on the fly very much, but if you need to and want to, somebody's off frequency a bit, just load the code in. It should go into there. Custom CW messages, you could do all of the transmit for QSO with this box through the web interface to set up the custom message, and off you go. The web page that I showed earlier is very noddy. It could do with some cleanups and more style sheets and all the usual webby stuff. But yeah, it's fine. Because it's set up as an access point, it would be quite easy to also link on to your 705 or 905 rig. Quite why you'd want to do, I'm not quite sure. I mean, you could, I guess, get it to set the IF frequency up on the rig, but it's not a big win, is it? It's one of those things you probably do. So it's very much a breadboard at present. I don't know whether it's worth putting PCBs together. It probably would be a little bit of work to do that. But yeah, at the moment it's all variable and kind of wire. But these are some of the things you can do. So this one was programming it up. So you can say that I want channel 2 to be 134.4 or 44.1 IF. It calculates the synthesizer register settings, and if you hit F2, it blows it on the board. So no need for a PC at all to do all of that sort of thing. And integrated is the weather box. So for this, you can either key in the distance or you can input the DX locator and it will calculate the distance. You've got the option to use either, and you'll get exactly the same kind of results as you would from just the standalone. Useful, nice signal, 55 carry to noise, but that's only for 1K. Quick discussion about Opera and WSJT. As I say, one of the options with the new synth is to go and put in the code to allow the small frequency shifts of a number of the modes. And I can guess, one of the things about Opera is on-off keying. It's really easy to do. But I think the UI is not great. and it's got this limited message structure and length, so you are stuck with it. And there's only ever been one version published with it, and I've always got the horror that at some point something somewhere will break, and they ain't going to fix it. EA5, Paul, I can't remember who wrote the code. I understand has no interest in going further with it. So you know, it is in some ways a dead end, whereas WSJT, I think, guarantee it's going to carry on for some time. In theory, you should be able to get capability as good as or better than Opera. It's only going to know in practice once we can get down and get the synth going in the small steps. With the new oscillator, it's pretty stable. It's much better than the 10 meg in the older board, and probably as good as some of the external 10 megahertz references. So with the 003 board, the board that we all have at the moment, it's not possible. You just can't shift the small steps required. But with the 007, with the changes, you can do that. So the way of doing it, so I had a chat with Andy, who seems to have done a lot of things like this with JT modes. You feed a zero crossing detector, you feed that into one of the ports on the PIC, and you just count time. It's very simple. That's exactly how the system works at the moment for both 10 megahertz and 1 pulse per second. They're not phase locked, it purely is pulse counting. So it just counts pulses and then adjusts the main oscillator to match. So you just have to basically count the intervals. If you know in advance which JT mode you're running, then it knows you can set the width of the detection window wider. Otherwise you're going to get into some DFTs or Gertzel algorithms. And IF is the same as now. You just get the IF out and the audio's in. So Andy has already done some work on something very similar with a slightly different ADF chip. So I'm pretty sure it will work. It's a question of whether it's worth the effort. Futures. So right now we're on 122, 134. Silicon Radar have announced a 240 gigahertz chip. Okay, which is quite nice. You know, it's a bit, well, it's the same size, so it's still a 5x5 QFN, so it's no bigger footprint. There's just some more pins because they've done some clever things that they want for the future. So, for example, you can feed in your LO if you want to, and you can get an output as well as the divided output. So the output is 3.5 gigahertz from the chip prescaler. Not a big change from the two that was already in use on the board. TX and RX enabled the same, so the isolated change, which is something that's different from the existing chips, in that you can turn off the transmitter when you're receiving. So that probably has some advantages. And it would be really nice if they came out with a 120 gigahertz chip that did the same thing, but who knows. There's a 15 gigahertz LO input output. It's designed for phased radar. So, you know, anybody want to do a 4x4 and put a lens in front of it? Somebody work out the spacing on the chips. And it's certainly doable. Whether anybody wants to do so, I don't know. IQ output's the same, so the IF arrangements are the same. 2 dBm output for one chip at 241 gigahertz. How about that? 16 of them. Wow. Yeah. So, you know, you can really think about some of the options that are possible with this new chip. It's also a single antenna, so unlike the existing designs where it's offset by 1.67 millimeters, it's only half a millimeter off from the package center, so you just have to be slightly off. But, you know, in terms of the existing design, it's a very simple win. So I think we can expect some new projects soon from those that have already been working on the 122 and 134 gigahertz devices. In fact, the very last bit in the Tubers article kind of hints at that, if you see that. Questions? Any questions out in the big wide world?
Yeah, you've got 50 viewers on there at the moment, so I just asked to see if there
Okay.
as far as VK, I think that's the furthest away at the moment. So.
It's not VK3CV, is it?
It's David, VK5KK.
Ah, okay. Well, he did get a mention earlier, so there we go. Cool. Thank you very much. Oh, Roger.
Question. If we can just once actually lose there you go. Okay.
Just something I want to know. Have they actually changed the coupler for the new board for 122124, or is it the same?
The chip has the same spacing on the antennas for the 122, 134 and the older chip, so it's exactly the same. You know, I think Silicon Radar clearly wanted it to be an upgrade for some of their customers, and therefore they didn't move it around.
That's great. A lot of people are going for the new coupler, thinking it's different. But okay, great.
The only thing that's different that's available is the IMU feed, which is better for the offset fed dishes rather than the chaparral feed, which is better for the prime focus with a lower FD.
Okay, great.
Anyone else in the room? Oh, one more here. I'm saving Graham running backwards and forwards.
Yeah, very interesting, Lehane. A very good talk. We sort of mentioned this last night in terms of backward compatibility between the 007 and the 003.
Yeah.
Are you intending to put the 144 shift in the 007 so you don't have to go back and modify your old systems that are all boxed up and working and you don't want to really start playing around with them too much?
I'm not quite sure I understand the question. So is it?
Well, yeah, sorry. Obviously we use a 144 dead split at the moment, don't we? You're advocating, for obvious reasons, 144.1 to become the sproggies or SDRs and 817s and things. But obviously a lot of people are currently, well, everybody is currently on the 144 split. And we don't really want to go back and start modifying our old gear rather than playing with a new one. So will the new one have 144 dead option? You know, because you can do what you like with the software, can't you?
Exactly. So by default, pretty much everything is either 144.1 or 144.4 from the stock firmware, rather than 144. I don't have the frequency table with me. It's back there. I've got it. We check later on, but I'm pretty sure everything's moved off 144 dead now in the stock firmware. It would be easy to change the old firmware. You know, it's relatively new to this board. If it's a big problem, it's a very simple change to firmware. You know,
everybody would have to do it, wouldn't they? That's the thing.
Yeah.
So
Yes, we would. Yeah.
Trying to keep it's the interoperability between the old board and the new board. I'm kind of a little bit worried about. So.
Yeah, it's as I say, it's easy to do. You can program the old board channel EF. That's the only one that it's allowed to do remotely with the PC, whereas on the new board, every channel is open.
Yeah. Okay. Yeah. Thank you.
Okay, all good. Mark, did you have a question? Sorry. Yeah. Okay. There's a question online.
You may be able to hear me, maybe not. So Gareth, G4X8T asks, are you releasing your new Weatherbox combined code?
If anybody's interested, yes.
Okay.
But it doesn't work on the old box, so you've got to start again.
Okay, yeah.
Because it works on the SP32S3.
Yeah.
So there isn't really a retrofit, it is a new build.
Okay, brilliant, thank you.
Okay, thank you very much, Lehane. That was intriguing. I'm not sure you answered my original question of how many of the original kits, but I suspect we can guess. But really interesting, huge opportunities in the future as well as the current technology. So thank you again, and can we show our appreciation?